Hello, hello. Thank you for joining me. Thank you very much indeed. So this is the first of 3 videos looking at the first chapter of Edexcel's A-level statistics. So although it says statistics and mechanics, it's because the book's split into 2. So the first bit is statistics, which we're doing now, and later chapters are for the mechanics. So I'm just going to pre-warn you, this is very definition heavy, lots of learning facts and definitions, not the most riveting, but very important all the same. So let's get warmed up with a few fairly basic examples. So here's 4 for you to have a go at now. So pause the video here, try these on your own, and when you're ready to see if you've got them correct, press play and compare your solutions to mine. Okay, I hope you've had a go at that. So let's have a look now together at question number 1. So for question 1, we have to factorise 2x squared minus 9x minus 5. So to do this, I'm going to show you how to use your calculator as well. But going back to GCSE, a method I'd try to use would be to say to people to take this 2 and multiply it by the n number, this minus 5. So essentially, forget about the 2 for a moment and replace this minus 5 with 2 times minus 5, which is minus 10. So rewrite it like this and then factorise it in the normal way. So 2 numbers that multiply to minus 10 but add up to minus 9. Well, those numbers would be positive 1 and minus 9. So I'm going to put x plus 1, sorry, minus 10, x minus 10. But that 2 obviously disappeared, so what we do now is we put it back underneath these numbers in the brackets. If we can divide, we do that. So 10 divided by 2 can be done, so that becomes 5, so that becomes x minus 5. However, 1 over 2 can't be divided nor can be simplified further, so that 2 instead gets popped next to the x here, so we have 2x plus 1. So that's the first one done. On your brand spanking new ClassWiz calculators, which I hope you've all got, or if you haven't, will have very soon, I'm going to show you how to do this using the equation function. Now, I know this isn't an equation, but imagine it's a quadratic, and imagine it's equal to 0. So if we go to menu, and scroll along until we get to equation/func and press equals, we're going to go for polynomial, so option 2, then press option 2 again, because we're trying to factorise a quadratic, and the highest power of a quadratic is power 2. So then type in what we've got. So we've got 2x squareds. The coefficient of the x is minus 9, so type minus 9. And finally minus 5, so type minus 5, press equals. Press equals again. The first value you get is the first root. So it's got a root when x is 5, so the factor is in the brackets x minus that value. The second one's slightly more complicated. This one, the factor, is x minus a half, so x plus a half, which we had here. So we always take this value and switch its sign over, so this minus becomes a plus, and that too, just remember to pop it in front of the x, and then you've correctly factorised it. Question 2. Write x squared minus 8x plus 1 in this form where a and b are constants to be found. All this means is complete the square. So x squared, instead of x squared we write x. We half minus 8, so it becomes minus 4. We now square the whole thing, and we always minus off this value squared. So 4 times 4 is 16. So for now we just simply rewrite the xy stuff, like so. Then, of course, just add on the plus 1 at the end. So, fully simplified down, we get x minus 4 all squared, then minus 16 plus 1 overall is minus 15. And again, I'll show you how you can get the ClassWiz to do this. So, on the ClassWiz, if we go to, again, menu, option A, not that one, sorry, that's a GCSE version with one, the A-level version. So we go to menu option A, press equals, go to polynomial option 2, degree 2 again. Then we type in, we've got only 1x squared, so type in 1, minus 8 for the coefficient of x, and the constant term is just plus 1. Press equals and equals again. These are the roots. These are useful if you're trying to factorise it. We're not, we're completing the square. So we toggle past x1 and x2. Now here, the minimum is this number in the bracket once the square's been completed. So it's this number with its sign switched. That's always the x-coordinate at the minimum. So this expression has a minimum when this bracket's equal to 0, and the bracket's equal to 0 when x is 4, like it says, because 4 take away 4, all squared is 0. And then this number at the end is the y-coordinate of a turning point. So if you press equals again, the calculator tells you that. So you've got on your calculator 4 and minus 15. So from the calculator, you just take the 4, switch its sign, stick it in the bracket, and minus 15 just copy out right next to the bracket squared, and that's your calculator doing it for you, essentially. Question 3. The number of pencils P found in 20 boxes is recorded in this table below. Calculate the mean number of pencils per box. I'll show you the GCSE way of doing it, and then I'll show you the calculator way, which is just a bit speedier and maybe more useful for A-level. So the GCSE way of doing it, I'd suggest to get an extra column drawn in, like so, and then we're going to multiply these values by the frequencies. So, first of all, 12 times 10, underneath our P times frequency column, 12 times 10 is 120, 15 times 4 is 60, 16 times 5 is 80, and the last one's 25. We now add all these together to get the totals. That's 285, and the total frequency is 20, but just check the question, it does tell you there as well. So you could have saved yourself a job by reading it. If not, just add these all up, get a total of 20. Now the mean is calculated by taking the total of this column, 285, and dividing by the total frequency. So we just do 285 divided by 20, press equals, SROD, 14.25. So the mean number of pencils per box is 14.25. There is a way, however, how the ClassWiz could have done this for you. So on the ClassWiz calculator, if you press menu, and then what we need to do is toggle along until we get to statistics. So if we keep going until we get to number 6, statistics, and press equals, what we want to do here is one variable calculations, because the only variable we're talking about is pencils. So press 1 for one variable, and then we just type in the number of pencils here, x. But as you can see, we need an extra column for frequency, but we can switch this on by pressing Shift, then Menu, then going down to where it says Statistics, so toggle down to number 3, then press 1 to toggle the frequency column on. We then type in the values as we need. So P, the first value is 12, press 12 and equals, and 15 pencils. The next one's 16, and press again 25. We then press right, toggle right to the frequency column, then press up to go up. So 12, the first frequency is 10, so type in 10, press equals, 4, press equals again, 5, equals again, then 1 can be left as 1. Once you've got all your data in, we press OPTN in the top left, and then we go to option 3, 1 variable calculations. Now here, we'll mention this in this chapter and chapter 2, all these different data points. The main one we need is x bar. That's what the symbol is for the mean. So the mean number of pencils is 14.25. So that's just how your ClassWiz could have done that for you instead if you were doing it manually. Let's have a look at the last warm-up example, warm-up question 4. So question 4 of the warm-up, the times taken in minutes by a group of students, T, to complete their maths homework is recorded in this table below. This one's a grouped frequency table. We're not told the actual exact times any students took to complete their homeworks. All we're told is that these first 2 students took somewhere between 0 and 10 minutes, the next 4 took between 10 and 20, and so on. We need to estimate the mean this time taken by these students to complete their homework. So first of all, doing it the old-fashioned way, what we'd need to do here is draw in an extra 2 columns. And you should remember from your GCSE days that to estimate the mean from a grouped frequency table, we need to take the midpoints as our estimate. So the next column here is for midpoint. Then once we've got the midpoints, we do midpoint multiplied by the frequencies. So in between 0 and 10, the midpoint is 5. Between 10 and 20, the next midpoint's 15. Then between 20 and 40, halfway of that is 30. The final midpoint is 50. Now we've got all these midpoints, we multiply them by the corresponding frequencies and write the answers in here. So the first one, 2 times 5, 10, 4 times 15, 60, 10 times 30 is 300, 2 times 50 is 100. Now we total up the midpoint times frequency column and the total frequency column too. We don't total up the midpoints, that just gives us a nonsense. So if we total all these up here, we get 470, and if we add all these up here, we should get a total of 18. Then what we do is we focus on the total midpoint times frequency, 470, and divide by the total frequency, 18. So our estimate for the mean is 470 divided by 18, which is 26.1 minutes. Now, using the ClassWiz calculator to do it for you, again, we'd press Menu, then go to Option 6, then one variable, and make sure you've got your frequency column turned on. Remember, if frequency column isn't turned on, press Shift, then Menu, scroll to Option 3, and make sure frequency is turned on. Now for X, what we do is we don't put in the times with these intervals. For the X column, we just type in the midpoints. So you need to work out the midpoints yourself at least. The calculator won't do that for you. So we've got 5, 15, 30, and 50 as our midpoints. Then toggle right and up and type in the corresponding frequencies. So the first frequency is 2, we've got 4, and a frequency of 10, and the final one had a frequency of 2. Press equals. Then once it's all typed in, press OPTN, press option 3 for one variable calculation. We're wanting X bar, and as you can see it's 26.1 recurring, which we've kind of just rounded to 26.1 like I did first of all. So that's warm-up completed. Let's now talk about the main bit of today's lesson. So, populations and samples. In statistics, a population refers to the entire set of items that are of interest, whereas a sample refers to a selection of observations taken from a subset, which just means a portion, of the population they are situated inside. For example, a population could be all adults living under a certain postcode area, and a sample from that population may just be to select just 100 of those adults. Or it could be, for example, a population could be all adults living in Halifax, and a sample could be those living in just postcode HX1. A census observes or measures every member of a population, every single member, so that takes ages. The UK government does this, of course, every 10 years to gather information on all households. If you're not familiar with this, ask your parents or carers, they will have had to have done one at some point, I'm sure. So there's a number of advantages and disadvantages to both a census and a sample. So thinking of a census first, the advantages is it should give a completely accurate result because it's actually testing every single member of the population. So it should be perfectly accurate in theory. However, because it's testing every single one or every single thing, it's very time consuming and can be expensive. As well as that, if the testing process destroys the item or it can't be used, then that could affect sales, for example. If it's a piece of fruit or some phone that needs testing, if you test every single phone, then they can't be resold because it'll be tampered with. So a census isn't always practical. A sample, however, we'll come to in a moment. Another disadvantage of a census is it's hard to process large quantities of data. So, for example, if you've just got like a normal laptop and you're doing like a census which is for thousands upon thousands of different population members, then it could be a lot of time to crunch those numbers. Talking of a sample now, so the advantages of a sample, it's less time consuming and far less expensive than a census is to carry out. Fewer people have to respond because it's just a portion of the population. And it's less data to process than in a census. So it's just easier to manage essentially, no matter which way round you slice it. It does have some disadvantages though. So the data may not be as accurate. Because a sample is a smaller number than a census, there is going to be some uncertainty, even if it is a good sample. As well as that, the sample may not be large enough to give information about small subgroups of a population. So for an entire population, there might be a few rare individuals with a certain, I don't know, genetic abnormality or a genetic condition, say. Even if a sample's big, those people might not be included. So a sample size needs to be very big indeed, actually, to get all the little subgroups in. So sampling does have its own issues as well, even though censuses are very hard to administer. So, like I was saying, the size of it is key when it comes to a sample. The size of a sample can affect the validity of any conclusions drawn. So, the size of a sample depends on the required accuracy and available resources. So if you need an accurate sample, you need to take one with a very large number of items in it. Resources there means time and money usually. So if time's limited or money's limited, that might put a cap on just how many people you can sample. So generally speaking, the larger the sample, the better, the more accurate it is, but you need more greater resources. And like I say, resources are normally time and money in this world. If a population is very varied, with lots of different subgroups and types of items in it, you'd need a larger sample than if the population were uniform. And by uniform, I mean much of a muchness. There's not much variation. So in a very varied population, that asks you, if possible, to go for a bigger sample size. Different samples can lead to different conclusions because no two samples are necessarily the exact same. And that will happen, like I said, because of natural variation in a population. Individual units of a population, they're called sampling units. And often sampling units of a population are individually named or numbered to make a list, and that list is called a sampling frame. The sample is then taken from the sampling frame. So the sampling frame essentially just translates the raw data into something usable, which can then be sampled. Let's now talk about a worked example together. So a supermarket wants to test a delivery of avocados for ripeness by cutting them in half. Suggest a reason why the supermarket should not test all the avocados in the delivery. If they tested all avocados, that would be a census of the avocados. But if they did that and cut them all in half, then none of them would be left to sell, unless they're sold as half avocados. If you split an avocado in half, then put it back together again, and said, no, you can buy this, customers would be thinking, what's going on here? So they couldn't really sell in the same way. So although you could do a census testing all of the avocados, all of them are going to go to waste. It's a lot of wasted money for a business, so they're not going to do that. It then says, before coming to part B, that the supermarket tests a sample of 5 of them and finds that 4 are ripe. So they estimate that 80% of avocados in that delivery are ripe, because 4/5 is 80%. Sounds fair. But what we need to do for part B is to suggest one way that the supermarket could improve their estimate. So sample size is key, the bigger the better, and a sample of 5 is very small. So the most obvious thing that could be done is the supermarket could increase the number of avocados in their sample, because 5 is obviously a very small sample size. So, next up, random sampling. So in random sampling, every member of a population has an equal chance of being selected. The sample should therefore be representative of the population. Representative just means it needs to reflect the true, general, overall picture. Random sampling also helps to remove bias from a sample. There's actually 3 main methods we're going to look at random sampling to cover in A-level. So the first method is simple random sampling. The next one is systematic sampling, and the last one is called stratified sampling. So let's start with the first one, simple random sampling, and what this means and how we do it. A simple random sample of size n is one where every item in the sample has an equal chance of being selected. To carry out a simple random sample, you need a sampling frame, usually a list of people or things to be sampled. Each person or thing is allocated a unique number, and a selection of these numbers is then chosen at random. There are 2 methods of choosing the numbers: generating random numbers using a calculator or computer or table of random numbers, and lottery sampling. The first method nowadays is much more practical and wider used. So using a calculator to generate random numbers is much more common now. In lottery sampling, which would be the second way of doing it, the members of a sampling frame could be written on tickets and placed into a hat. Then the required number of tickets would then be drawn out of the hat or container, whatever they're put in to be drawn out of. That's old-fashioned. For example, like using it as a raffle. It's still used, but because it's more time-consuming, you need paper, it's more of a faff, it's more of an effort. Usually the easiest way now is just to use a calculator or computer to do random numbers. So let's have a look at a random sample, a worked example with simple random sampling. We've got 100 members of a yacht club listed alphabetically in the club's membership book, and the committee wants to select a sample of 12 of them to fill in a questionnaire. Explain how the committee could use a calculator or a random number generator to take a sample of the members. A simple random sample, that is. So I'm going to show you how to do this on the class quiz as well. So allocate each member an integer, which is a whole number, from 1 to 0 inclusive. Then these 100 people could then be selected using the calculator by typing ran int hash, then in brackets 1 to 100, close brackets, using the random number generator on the class quiz. So let's start this first. So what we do here, first of all, get into normal mode, because it's in stats mode. We need to find that function. You can see here it should be above what is for you your decimal. So we press alpha decimal. Don't worry about mine being a comma, that doesn't really matter. But we type in 1, then we need the comma button. Now for you, the button you need to press is above this right bracket. Don't worry about my symbol. So it's shift bracket, then 100. Then close the brackets, and then next time we press equals, that will generate for us a random number. So for example, if we press equals, our first random number between 1 and 100 is 58. So what we do now is we generate 12 unique integers. So I'd have to press equals another 11 times. And each random number I get corresponds to the person I'm selecting who's been allocated that number. So whoever's been given number 58, they're chose as my first one to take from my simple random sample. If I press equals again, 37, that's the next person to take, number 37. Press equals again, number 32, and so on and so on. However, because what's being generated is random, it could be that a number which has already come up is generated again. If that happens, just simply ignore any repeated random numbers generated and generate a fresh one. That's all you need to do. Part B, explain how the committee could use a lottery sample to take a simple random sample. Similar idea, just without using a calculator. Rewind 100 years, if you didn't have a calculator, how could we get a similar result? What we could do, we could write all the names of the members on identical cards or pieces of paper and place them into a hat or some sort of suitable container. I mean, who has a top hat now anyway? Then draw out 12 cards, and those 12 cards will correspond to the 12 selected members. Systematic sampling is slightly different. So in systematic sampling, the required elements, required sampling units, essentially, are chosen at regular intervals from an ordered list. So for example, if a sample of size 20 was required from a population of 100, we could take every fifth person, because 100 divided by 20 would be 5. But really important, the first person needs to be chosen at random. So you can't just go and say, well, I'll pick number 5, then number 10, then number 15. You need to pick a number at random. So we could use that random integer generator on the calculator I showed you earlier. So for example, if number 39 was chosen first, and because 100 divided by 20 is 5, the list would be generated by going back and forth in 5s. So 39, the next one along would be 5 more, then 5 more, and counting down to get the lower ordered numbers, we'd count back in 5s. So 34, 29, 24, and so on and so on. So we've got a full list from being in single digits up to 99 or whatever. So there are two methods how to choose the numbers. So the first number could be by using a random number generator on a calculator, and the other one could, again, the first number could be chosen by doing a lottery sample. And again, we've talked about what lottery sampling is. It's where the members of a sampling frame could be written on tickets and put into a hat or container, then the required number of tickets are then drawn out. So the next one we're looking at now is stratified sampling. So in stratified sampling, the population is divided into mutually exclusive, which means non-overlapping strata. So it could be males and females, or boys and girls, something like this. And then a random sample is taken from each. It's much easier when you actually come to do it, don't worry. So the proportion of each stratum, which just means each layer sampled, should be the same. A simple formula can be used to calculate the number of people or things we should sample from each stratum, each layer. So the number of people sampled in a stratum is the number in that stratum divided by the number in the entire population multiplied by the overall sample size. So what this means is it's just basically finding a fraction of an amount. So it's easier by doing a worked example, like I've said. So let's just do one straight away. So we've got a factory manager who wants to find out what her workers think about the factory canteen facilities. The manager decides to give a questionnaire to a sample of 80 workers. It's thought that different age groups will have different opinions. So we've got all these different workers at different ages. Explain how this manager could take a sample of 80 workers stratified by age to find out the workers' opinions. Well, first of all, the sample needs to be 80 workers, but in total here there's more than 80 workers in the factory, obviously. So the population is 75, aged between 18 and 32, then another 140 between 33 and 47, and the more senior members, 85 of them, between 48 and 62. So actually, in the entire population, there's 300 workers in total. So just thinking about the different age groups now, those that are between 18 and 32, 75 of them are between those ages. So 75 out of 300 is the fraction aged between 18 and 32 in the factory. Therefore, we need that same fraction in our stratified sample. So we need 75 300ths of 80. So it's that same fraction of people in that age group out of a total in the population multiplied by sample size. It's that fraction of sample size each and every time. So on the calculator, that comes out as giving you 20. Therefore, we'd pick 20 people aged 18 to 32. For 33 to 47, there are 140 people out of 300 in that age group. So just under half. Just under half in the population. We need just under half in our sample. So that fraction times 80 gives us an awkward decimal. Because we're talking about numbers of people, it needs to be rounded to the nearest whole number of people. So we get 37. The final one, 85 out of 300 people are between 48 and 42 in the entire factory. So we want that same population of people in that age group for our sample. So for the 48 to 62 year olds category, we need 85 over 300 times 80, which gives us 22 2/3, which needs to be rounded to 23. So in terms of explaining how she's done that, what we do, or what she needs to do, is number the workers in each age group, starting with the young ones, 18 to 32. Label these on the calculator, numbers 1 to 75. Then we can use the calculator random integer function to generate 20 unique integers that will correspond to workers picked from this first group. And then you'd ignore any repeated integers and just generate a new one if that happened. That's how you could pick all the members from the 18 to 32 group that are going in our stratified sample. Once that's done, we repeat the process for the 33 to 47 group and the 48 to 62 group. Any difference would be for the 33 to 47 group, what we'd need would be to generate 37 unique integers, and then for that one to generate 23 unique integers, because these are different stratum sizes for 33 to 47 and 48 to 62. So, to summarise, those simple random samples, each one of those three we've looked at, has its own advantages and disadvantages. So let's just think about each of these. So the simple random sampling, the advantages of this, it's free of bias because it's completely random. It's easy and cost effective for small populations and small samples. It's quick and easy to administer and to actually carry out. Also, another advantage is each sampling unit has a known and equal chance of selection. So it just ties into the first point that it is free of bias. Some disadvantages. It's not suitable when the population size or the sample size is very large, as it's potentially very time consuming, disruptive and also expensive. Remember, surveys, questionnaires and sampling are real life things. It's not pure maths, this is applied, so time and money always need to be taken into account. And a sampling frame is needed as well, that's a big thing. You need to comb through all the raw data and put it into a usable sampling frame. Systematic sampling. Advantages, Again, it's very simple and quick to use. It's suitable for large samples and large populations because you just generate how many need to be sampled every 5 or every 10. But disadvantages, again, a sampling frame is needed for that one, and it can introduce bias if a sampling frame used is not random. Finally, stratified sampling. Advantages of this one. The sample accurately reflects the population structure because it puts it into strata, it puts it into layers, and makes sure we're picking the same proportion of layers in the population as what we want in our sample. In other words, it guarantees proportional representation, like I said, of groups within the overlying population. Disadvantages, well, the population has to be able to be categorized into non-overlapping strata to begin with. If it can't be, you can't use stratified sampling at all. So it can only be used if a population is ready for it, if that makes sense. And also as well, the selection within each stratum, within each layer, suffers from the same disadvantages as what you'd have found in simple random sampling. So again, for example, what if your population size is huge and you need like a really big stratum? That could be very hard as well. So after all that, what I want you to try and do now is exercise 1B, starting on page 6 of the Stats and Mechanics book in front of you. So I would suggest reading through the book on your own as well to redigest what I've said, try the questions slowly and steadily and see how you get on. Check the solutions at the back. If you're still stuck, ask me in person or on the comments and I'll do my best. Thanks for listening and I'll see you all soon.